I'm Dr. T, and welcome to my office. So today I would like to continue the discussion of separating out chemicals by discussing a set of techniques that are some of the most popular ways of separating out chemicals. And that is chromatography. Chromatography comes from the Greek to separate colors, because that was one of the early ways that we realized that this technique was a thing. We would separate out different dyes. If you've ever done the experiment with a coffee filter and some food coloring and let the water wick up the coffee filter and separate out the food coloring, that's chromatography. Or I should say one type of chromatography. So the core of chromatography really involves three things. Of course, you have the thing that you're trying to separate out, your mixture, and then you're going to have two parts of your apparatus. The first we call the stationary phase, and this is going to be part of your apparatus that doesn't move. Typically, for most chromatography, this is going to be some kind of powder that gets either packed into a column, what we would call column chromatography, or put thinly on a sheet, which is what we would call thin layer chromatography. But it doesn't actually have to be. In another video I discussed gas chromatography, and the stationary phase, the part that doesn't move, was actually the walls of the thin glass capillary that's involved in that particular apparatus. The next part is going to be the mobile phase. So the stationary phase stays still, the mobile phase is going to move. So that's typically going to be a solvent of some sort. So in the coffee filter example, the coffee filter would be the stationary phase, and the water wicking up the coffee filter would be the mobile phase. And thus, if we have, say, a liquid mobile phase going through a powdered stationary phase in a column, we would call that liquid column chromatography. In the gas chromatography example from earlier, that would be carrier gas, the helium that kind of gives everything a nudge. So typically this is a liquid, but it doesn't have to be. I don't know of any examples, though, where it's a solid, because that would be kind of weird. That said, it doesn't mean it doesn't exist. There's all kinds of weird and wonderful techniques out there. Okay, so the common approaches to chromatography, what it's really doing is exploiting how much the substance you're trying to separate is sticking to the stationary phase versus the mobile phase. And what we're not usually doing is having it stick fast and not move, although there are techniques where that is done. Typically what you're going to have is something that's in equilibrium between the two. So I would have a couple of different chemicals that I want to separate, and as I'm trying to separate them, one chemical is going to spend some of the time on the stationary phase and some of the time on the mobile phase, and it's going to go back and forth. And the other chemical is going to be doing the same, but it's going to stick a little bit more towards the stationary phase. Now, when the chemical is bonded to the stationary phase, once it's attracted to the stationary phase, to the point where it's not moving, it's not moving. Now, the mobile phase is traveling through your chromatography apparatus. So either through the column, or being wicked across the paper or the thin powdery film of the TLC, aka thin layer chromatography. And as it's doing that, if it's in the stationary phase, it's not moving. But if it's in the mobile phase, it's traveling. So those compounds that spend more time with the mobile phase will come out quicker, because they're spending more of their time moving, than those compounds that stay with the stationary phase. Therefore, your intermolecular forces typically are going to be a little bit different between mobile phase and stationary phase, and thus you're going to, set up a preference. For things like column chromatography, this is a great way of purifying. You can even do fairly large batches, although you're going to need a big column to do that. Other techniques like thin layer chromatography, this is not usually used for purification because the amount of material you use is just too small, but it is a great way to monitor your reaction to see if you are actually forming your chemical of interest. Does it travel to where it should on your plate? Or do you have a mixture? Do you have more than one thing traveling across your plate and thus ending up in different locations? So it's a nice way to monitor your experiments. So with that said, I'll see you in later videos. Have a wonderful day.